So in this video, we're going to do some problem solving with patterns. And in the first example, we would like to construct a difference table to predict the next term of the sequence. So let's go ahead and do that. I'm going to start by writing down the terms in the sequence. The first term is 7. Okay, the second term is 10. The third term is 13, and then we have 16, and we don't know what the next term is, so that's a big question. So when we make a difference table, we just look at the first two terms and we say, what is 10 minus 7? And we can see that that is 3. So what I'm going to do is I'm going to write the difference here. And then I look at the next two terms, 10 and 13. 13 minus 10 is 3 also. And now I'm going to look at the next two terms, 13 and 16. And I can see that 16 minus 13 is also 3. So it seems like all I'm really doing in this sequence is I start with 7. We add 3 to get 10. We add 3 to get 13. We add 3 to get 16, etc. So the next term can be gotten by just adding 3. So the next term appears to be 19. Okay, and so that would be our final answer, 19. So let's do another example. So we're going to once again construct a difference table to predict the next term of the sequence. So I'm going to go ahead and I'm going to write the terms of my sequence down here, the ones that I have. I have 1, 6, 16, 31, 51, and then we don't really know what comes after 51. Okay, so once again I start by looking at 1 and 6, and the difference between 1 and 6. 6 minus 1 is just 5, so I'm going to write that down. Now I look at the next two numbers, 6 and 16. The difference between 16 and 6 is actually 10. Okay, so it's not equal to 5, but that's okay. I'm going to keep going because I'm constructing the difference table. So now I look at the next two numbers, 16 and 31, and the difference between 31 and 16, so 31 minus 16 is 15. Okay, and I continue in this manner. The difference between 51 and 31 is 20. Okay, and then I don't have any more numbers to go by. So you can see what's interesting in this case is instead of having like 3, 3, 3, 3 in the previous example, we have 5, 10, 15, 20. So what I'm going to do is I'm going to use these four numbers, 5, 10, 15, and 20, and I'm going to repeat the process. So I look at 5 and 10, and I say, okay, what is the difference between 5 and 10? 10 minus 5 is 5. So I'm going to write that difference on top. And now I'm looking at 10 and 15, and once again 15 minus 10 is 5. And now I'm looking at 20 and 15, so 20 minus 15 is 5. And so you can see now I can see a consistent pattern happening. So that means in order to get the next red number, what do I have to do? I have to add 5. Okay, so I'm going to do that, and that will lead to the number 25. And so now I know what I must add to 51 in order to get the question mark number. So in this case, we have 51 plus 25 is 76. And so that was our missing number, and that's our final answer. The next term in the sequence is 76. Okay. So we just repeated the process with the difference table twice until we got, and you can keep going. Sometimes even these numbers won't, you'll have to repeat the process another time. Okay, so let's do another quick example involving sequences. So sometimes a sequence is defined using a formula like this one. So this means that the nth term of the sequence is given by n squared minus 3n divided by n plus 1. So what does that mean? So let's just write out the first three terms. The first term is denoted with the subscript 1, so we have a1. And it looks like we're going to have 1 squared minus 3 times 1 over 1 plus 1. And this gives me, I square the 1, I get 1 minus 3 over 2. So 1 minus 3 gives me negative 2 divided by 2. So the first term of the sequence is negative 1. The second term of the sequence, so wherever I see the n, I'm going to be plugging in a 2. So this would give me 2 squared minus 3 times 2 over 2 plus 1. So I square first because of the order of operations. So that's 4 minus, and then I'm going to multiply these guys. I get 4 minus 6 over 3. And that leads to negative 2/3. And I'm going to continue the third term of the sequence. So now wherever I see n, I'm going to plug in 3. So I have 3 squared minus 3 times 3 over 3 plus 1. Okay, and then I have, this is 9 minus 9 over 4, which is 0 over 4. And finally, we have 4. So that means the first three terms of the sequence are negative 1, negative 2/3, 0, and then we can keep going as long as we want, but those are the first three terms. Okay, in this example, we want to find the third and fourth terms of the recursive sequence defined by, okay, so the first term is 3. The second term is 5, and the nth term is given by the term before it plus twice the term that was 2 before. So in this case, let's take a look at what, let's compute the third term of the sequence. So if n is equal to 3, then this formula is telling us that in order to compute the third term, we take the second term, so this would be a3 minus 1 plus twice the first term, because this is just 3 minus 2. So I'm just going to rewrite that as the second term plus twice the first term, and that is equal to 5 plus 2 times 3, which is, so this is 6, right? So we have 11. So that is the value of the third term. So to calculate the fourth term, I'm again going to use this formula, and I have n minus 1 would be 4 minus 1 plus 2 times a, and the subscript is giving me 4 minus 2. So this is the third term plus twice the second term. So that is equal to, the third term is just this guy. So we have 11 plus 2. The second term was given as 5. So 2 times 5 is 10. So 11 plus 10 would give me 21. So that is the third term and the fourth term.